kids on diets. Let's talk about what kind of diets they could go on. So we got a no sugar diet, right? No sugar. What other?
No caffeine.
No caffeine.
No carbs.
No carbs.
No chicken nuggets?
No chicken nuggets.
Mystery meat.
Vegetarian, what's for vegetarian?
No
Now,
additives and preservatives.
and we're being very loosey-goosey with how we're describing these things, right? But what would there also have to be at some point in the study to compare all this to? This is a term you might not be familiar with yet, but go ahead, Brandon.
You have to have kids that were on a lot of sugar and a lot of caffeine.
You'd have to have what's called a control of some kind, which would compare the others to. As Brandon's indicating, he's looking for an A switching to a B. And they could each be ABs. You could have a kid that was on a terrible, terrible sugar diet and then take them off of it and see what happens. And I say a kid, it's a group of kids, obviously, it's a sample of kids. You don't want anecdote, you want results. So suppose we've got a few, and we're being very loosey-goosey with how we're designing this experiment intentionally, because I'm not worried about the scientific design. I'm worried about how they could have gotten that headline, yeah? How could they have gotten that headline? So it looks like studies show that diet may trigger adverse behavior. How? What's adverse behavior mean?
They'd have to define that.
They'd have to define that. You guys take a stab at it right now. Define adverse behavior. I love this. I love what you're saying.
Misbehavior.
Misbehavior where?
In the class.
Maybe in the class. Define misbehavior. I love this.
Behavior outside the norm.
How are we metricing norm?
No, you can't.
Well, let's just try. I'm not saying you can or you can do it.
Just call it the average.
Well, give me something we can measure or count in a classroom.
Like how many outbursts they have.
How many outbursts? Once we've defined outbursts, we're getting more macro to micro. You guys getting that? I love what you're saying, and I'm not saying there's right answers. This is the problem with research. We can always pick holes in how they measured something. And Sean, you just admitted to it. Very well, I might say. So yes, we've gone from adverse behavior, right, to a number of outbursts as long as we have defined what an outburst looks like. Right? I mean, technically speaking, I outburst for 2 hours in here with you guys every couple days. But if we've defined it as like a negative behavior outburst, awesome! So now we've got a number line, right? And we could do number of outbursts. Right? We can plot that. We can plot that. Better yet, we can build a confidence interval around it, can't we? Because we've got at least 5 samples here. We've got at least 5 samples. And we can put these kids on this diet for, I don't know, whatever, 60 days, 90 days, I don't know how long it would take. It would take some length of time, I'm assuming. Okay, you ready? Okay. Now, what happened? Let's call no sugar blue. And let's put the minimum number of outbursts at 0, just because that seems to make sense, right? Where do you think the confidence interval would be for a no sugar diet in a 1-hour classroom? How many outbursts do you think they're going to average? Make up a number.
What age kids are...
Make up an age. I'm trying to be very loosey-goosey with the research methodology, focused on the conclusion.
Fewer.
8-year-olds.
Okay.
8-year-olds. I was diagnosed at 6. We'll go with 8. I feel a little better about it that way.
8.
How many?
Fewer.
Fewer than what?
Fewer than usual.
Than the control?
Yeah.
Okay, so I'm using this word control. All control means is they haven't had any experimental effect done to them. Does that make sense? We'll come back to that phrase over and over again today. So let's throw the control group up then. How about we do that, Chris, instead? Where should the control group go? We'll start with that. What should they be centered on? 0, maybe? Should they be centered on 0? Maybe? Maybe. Not good kids. Kids that aren't adversely behaving will outburst from time to time. They're 8, right? So why don't we put their interval somewhere between 0 and, say, 2? How about that? And I'll leave the number off if you don't like 2. If you think 2 is too high, I'll just start it at 0 and go out to something. Where should the sugar kids go? Where do you think the sugar kids would go?
In the middle.
In the middle? Tell me where to start them, Elizabeth.
All right there.
Not right here?
Yeah.
Okay. Sugar. Tell me where to stop them.
That's good.
Good! More variance. I love that. Non-uniformity. Very nice. Okay. So this, I believe, would be supporting evidence for that headline. Studies show, some study was done, data was collected, we counted a number of outbursts, that diet may trigger adverse behavior if, and Sean, I understand you're going to be upset with this statement, if we've determined number of outbursts, I love that, Casey, if we determine that as an accurate measure of adverse behavior, do you see that on average, kids on the no sugar diet have, we should call it the sugar diet.
Yeah, you have it.
Let's call it the sugar diet. Sorry, I did it backwards. Kids on the sugar diet have more outbursts on average than the kids on the no sugar diet. Is that fair? How can we tell this statistically? Forget the research methods. How can we tell statistically?
Don't overlap.
Because they're not overlapping. The intervals are not overlapping, which means the fish that represents the number of outbursts of the control group, even at its highest, is lower than the lowest of this one. Is that fair? How confident are you in your result? How confident are you in that result?
I'm 95%.
95%, as are most researchers. As are most researchers, they're 95% confident in their result. Good! Could you be wrong? Well, yeah. With what likelihood?
5%.
5%. That's called a type 1 error. False positive. Saying they're different when
They're not.
they might not be. Good, they're not. I like that. Saying they're different when they're not. That is a type 1 error. And we run that risk. Whenever you run a statistical analysis and you say, they're different, you might be wrong. 5% of the time on average is what, if you're sticking with 95% confidence, that's generally where you stick. Is that fair? Okay, good. Now, let's do the vegetarian diet. Let's do the vegetarian diet, just to prove another point. Fair so far? Let's say the vegetarian kids came in looking like this. Compared to the control group, how do the vegetarian kids compare? Can you make a conclusion about their behavior compared to the control group?
No significant difference.
No, say it again.
No significant, I can't say it.
It's okay, I know what you mean. There's no significant difference, statistically significant difference, or significantly is enough, between the control and the experimental group, in this case the vegetarian group. Nice. So you probably wouldn't read about this in a headline. It's not newsworthy. We checked vegetarianism, and there's no difference. I mean, that's not the kind of thing you read about very often. But maybe you should, because you could be wrong there, couldn't you? You may have gotten one of those goofy, deviant outlier data points, right? This might be wrong. Maybe this is supposed to be way over here. Maybe it's supposed to be down here. I know you can't be below 0, but technically speaking, it could be left or right. It could be that this interval doesn't touch, just like it could be these intervals do touch. You see the other kind of error you could have? A false positive is when you get intervals that don't touch, but you shouldn't have. A false negative would be when you get intervals that do touch when they actually shouldn't. You don't read about false negatives very often. Think about when the people fail their drug tests. Do they complain about false negatives? I don't think they do, unless they're completely stoned, right? False positives, as well you should. If you get a false positive, you should complain. You were clean and you got tested positive, or you don't have the disease and you tested positive. Those are the ones you hear about. Those are the ones people lose their jobs on, right? False negatives don't cause anybody to lose. Nobody has repeated tests for a false negative. No, I don't believe I'm clean. You better test me again. You don't hear about it, right? You laugh, right? But we don't hear about that very often. But do you see how it could be important from a research perspective? Nah, there's no difference in diet. What if there is and you're missing it, correct? Maybe you better do what? Another test. Bring the power up by increasing your sample, because if you do that, you might actually see. And we'll get into that talk more and more as we go through this class too. So there are two ways to be wrong. Just want to put that picture in your mind right now. Put that picture in your mind right now. And there are ways to mitigate confidence and increase power and all that kind of wonderful stuff. But you generally read about this kind of situation in the news, not about this kind. Studies show we can't find an effect. I mean, that doesn't have the same ring to it, right? As studies show don't walk barefoot in that cow patty, you'll catch Ebola. That's the one you're going to hear about. Studies show if you walk barefoot in a cow patty, you're not going to catch Ebola. Like, why would you waste your time writing that? Well, I think it's kind of cool to waste your time writing that, because that might be wrong, number one. And number two, okay, it opens up something. But that's just my statistical opinion, not necessarily a CNN writer's opinion. Making sense? You guys buying this? Okay, good. All right. Let's look at some more.